Hi, this is Mrs. Myers, and this is our review sheet for Chapter 4, Geometry 22. Just going to explain through this review sheet. Make sure you pay attention, especially on page 2. You're going to want to pay attention in the middle of that page. So in triangle HFD, what angle is included between DH and DF? What you want to do is draw the triangle first, triangle HFD. Figure out which is DH and DF, and the included angle is the one that's formed by these two sides. So it's going to be angle D in this case. Kind of when we use, like when we use SAS, it's the included angle. And then this is going to be the included side in triangle OMR. What's the included side between angle M and angle R? What connects angle M and angle R? Well, just MR. So that's, you could almost do that without even looking. Angle D is common to both of those, and between M and R is just MR. Okay, which postulate or theorem, if any, could you use to prove the triangle's congruent? Sometimes there's not going to be enough information, but here we've got reflexive property, so we can mark that one. We have no reason to mark anything else on this diagram, so this is actually not enough information. So we're just going to write none or not enough information. For this next one, again, we have no justification for marking anything else congruent or anything here. So again, not enough information. Here we can justify marking these two angles congruent because they're vertical angles. So this is going to be SAS. The angle is included between the two sides. And D, we have, if we cover up one triangle and we just look at one at a time, we have two angles and a side on one triangle, and the side is not between the two angles. This would be the side between the two angles, and that's not what's marked. So it's going to be A, and the S not between the two angles. Here we have a reflexive property. We could mark the common side congruent. Again, look at just one triangle at a time. You've got a right angle, a leg, and a hypotenuse. So this is going to be hypotenuse leg. You may have at first thought ASS, but we know that's a bad word. So when the A of ASS is a right angle, it's going to be HL. Here we can mark the reflexive property again, which gives us three sides on each triangle marked. So that's SSS. And part G here, again, we have vertical angles congruent. So you have one triangle at a time. Again, just look at one triangle at a time. You've got angle, side, angle, with the side between the two angles. And for this one, they have a common side. One triangle at a time, you're going to look at side, side, where the angle is between the two sides. All right, look at the next page. How can you use congruent triangles to prove the statement true? Both of these, you can use congruent triangles. Here we could prove the triangle's congruent by AAS, but this question is asking what can we use to prove these two are congruent after we know these triangles are congruent. So if we already know the triangles are congruent, we can then say these extra sides, TV and YW, which weren't marked to begin with, now we could say they're congruent by corresponding parts of congruent triangles are congruent. And now I'm going to let you use the CP/CTC if you want to. And that's the same answer here. By reflexive property, we could get these triangles are congruent by ASA. But the question is asking how could we get BE congruent to DE, which are two parts that aren't marked congruent yet. So again, it's going to be corresponding parts of congruent triangles are congruent. Find the values of the missing variables. So we have to find X, and we have to find y. Notice y is y degrees, so that's the angle we're looking at. Here this x is right by the side, so we're looking for the length of the side. Well, this triangle is marked with these two sides congruent to each other, which makes it an isosceles triangle. If this side is 4 and it's congruent to this side, well, x just must be 4. It has to be 4. We learned isosceles triangle theorem, which says if two sides are congruent, then the angle across from the two sides are congruent. So we're going to mark this one and this one congruent to each other. So if this one is called y, this one could be called y also. So in our big triangle, we've got 3 angles of a triangle add up to 180. So 50 plus y plus another y equals 180. 50 plus 2y is 180. 2y is 130. And y is 65. So y is 65 in this case. For this one, we've got this obtuse angle here is 125. It forms a linear pair with x. So x plus 125 equals 180. And so x is going to be 55 degrees. If that's 55, then its vertical angle is 55. And since this triangle is an isosceles triangle, the angles across from those two sides are congruent. So this would be y as well. So again, you have 55 plus 2y equals 180. And then when you solve for y, you get 62.5. Okay, so let's move on. But I said to pay attention in the middle of this page because I would like you to write your birthday at the bottom of your test paper when you're taking your test. Write your birthday. Write out the month. Like mine is May 2nd, so I would write M-A-Y with a 2 at the bottom of the test paper. Okay? That'll get you an extra point so that I know who watched this video. Don't tell everybody. Okay. Now, part C, we've got another isosceles triangle right here. Anytime you see an isosceles triangle, you should automatically look across from the congruent sides and mark the two angles congruent. Every time you see an isosceles triangle, mark the angles congruent. So if this is x here, this has to be x here. These two angles are congruent, they're both 25. We learned the theorem that says when you have the bisector of the vertex angle in an isosceles triangle, then it's the perpendicular bisector of the base. So that means y has to be 90. And if y is 90, we have a triangle here with x plus y is 90 plus 25 equals 180. And so x is going to turn out to be 65 when we solve that. Part D, equilateral triangle. This is an equilateral triangle. All the sides are equal. We learned that in an equilateral triangle, every angle is 60 degrees automatically every time. Equilateral triangles, every angle is 60 degrees. So y is easy, 60 degrees. If all the sides are the same length and this side is 7, x is 7. Problem should take you about 3 seconds to do. Okay, part E here, you've got two triangles that are congruent to each other because this angle is congruent to this angle, this double angle is congruent to this double angle. Therefore, well, and the side is congruent to the side. So by ASA, these two triangles are congruent, which means these angles, the missing angles, must be congruent to each other. So 3x has to equal 108 Remember, when you're writing your equation has to make sense to your diagram. And this makes sense because these are corresponding parts of congruent triangles. So they have to be congruent, which makes them equal to each other. So that should be 36. Okay, some proofs here. Oh, not yet. Sorry, number 6. We have an isosceles triangle with right angle B has point D on AC such that BD is perpendicular to AC. So isosceles triangle ABC, A, B, C, with right angle at B has a point D on AC such that BD perpendicular, it means it forms a right angle with AC. The relationship between triangle ABD and CBD would be that they're congruent. This is isosceles triangle. This is reflexive. They're congruent by HL. Okay, number 7. Given DE is a perpendicular bisector, these are two big words here. Perpendicular means right angles, right? And bisector means split into two congruent parts. Don't forget that. So let's mark this on our diagram. Remember, read your given, mark your diagram every single time. Read your given, mark your diagram. So DE is perpendicular bisector of FC. Perpendicular means that's a right angle. So is that. Bisector means that FE is going to be congruent to EC. It cuts FC in half. DF is also congruent to DC. So we have a lot marked on this diagram. Looks like we're going to be able to use HL theorem. It's just what I'm thinking. We're going to prove F is congruent to C, F congruent to C. I'm not going to mark them congruent yet because I don't know they're congruent. I have to prove they're congruent, so I'm not going to mark them congruent yet. All right, DE is perpendicular bisector. That's given. That makes these two that we marked right angles by the definition of perpendicular. Now, in order to use HL theorem, one of the statements we have to say is that the triangles are right triangles by definition of right triangles. Right triangles, not angles, but right triangles. That's one of the criteria for using HL. Okay, FE is congruent to CE. That is the definition of bisect. Right? We marked FE congruent to CE because of that. DF is congruent to DC. That was given. Now we have everything marked. We could say the two triangles are congruent by HL because we have hypotenuse here. Nope, hypotenuse here, legs here, and the right triangles there. Now we could say angle F is congruent to angle C by CPCTC. Okay, given BD is congruent to BE. Again, read your given, mark your diagram. BD congruent to BE. Measure of angle 4 is 50 degrees. We want to prove that the measure of angle 2 is 80 degrees right here. I'm trying to prove that one. I like to put a little dot on the one I'm trying to prove is congruent. So BD is congruent to BE, and angle 4 is 50. That's given. Angle 4 is congruent to angle 5. Well, if these two sides are congruent, then automatically we said isosceles triangle, we have to mark the opposite angles congruent. So 4 is congruent to 5 by the isosceles triangle theorem. That's how 4 is congruent to 5. Then their measures are equal by the definition of congruent. Remember, anytime we go from same angles being congruent to equal or equal to congruent, that's going to be definition of congruent. This next one, the measure of angle 5 is 50. Well, if 4 is 50 and 4 is equal to 5, then 5 is 50 by substitution, or you could have used transitive here. And then measure of angle 2 plus 4 plus 5, these three angles add up to 180 by the triangle sum theorem. And then we're going to substitute 50 in for both of those. That's substitution. And then we just combine like terms or simplify. And then we can say the measure of angle 2 equals 80, which was what we're trying to prove, by subtraction. Subtracting 100 from both sides. Okay, on the last page, I have this separately here. This was practice with common terms. I'm not sure if this is the exact one that you had, but we're going to do this one anyway. XY is the bisector of VW. So it's going to cut VW right in half. You're going to have VY congruent to WY. Okay, and number 2, GE bisects angle FEH. So let's try to find angle FEH is this big angle. If GE is bisecting the angle, we mark 2 angles congruent. It's got to be angle FEG congruent to angle HEG. JL is the perpendicular bisector of KM. JL is perpendicular, which makes that a right angle, and the bisector of KM, segment KM. So we have to mark 2 segments congruent. So the congruence here is going to be KN, congruent to MN, and we also, by perpendicular, we can say that angle, any of these 4 angles actually, angle KNJ, let's say, is a right angle. All right, and number 4, and O is parallel to QP, and O parallel to QP. Whenever we see parallel, we should be looking for certain angles congruent, and in this case, we could have this angle congruent to this angle by alternate interior angles. So that would be angle NOQ, NOQ, congruent to angle PQO. You actually could have had another pair here of alternate interior angles, this one, and that would have been angle O and P, congruent to angle QP, and either one of these is okay. Number 5, TR bisects angle SRU. Angle SRU is here. And if TR bisects this angle, we're going to cut this angle into 2 congruent angles. So we have angle SRT congruent to angle URT. Number 6, point R is the midpoint of QO. Midpoint of segment QO. So just segment QO is getting cut into 2 congruent pieces. So you should have QR congruent to OR. Name a linear pair from this diagram. Could be any of these that are formed in here. I'm going to say angle NRO and angle ORP. This one and this one. Okay, and XY is perpendicular to VW. Perpendicular just means a right angle. That's all you can mark when you see that symbol, perpendicular symbol. That's all you can mark. It's not always a bisector. This doesn't say perpendicular bisector. It just says perpendicular. So angle XYV and angle XYW are right angles. Okay, that's it. Don't forget the trick, and good luck.